Hi, I'm Chris Dale. This is my submission for the SANS Spectacular Pen Test video contest. In this demonstration, we're going to show you how to do file inclusion vulnerability exploits and how to leverage it against shell. Let's get to it.
For this demo, I'll be using the damn vulnerable web application. I'll log on with the admin user. Password is password. And here we are. This is a great tool for demonstrating vulnerabilities. For our example, we'll be using the file inclusion demo. This is a vulnerable script, and we can even click view source if we wanted to have it reveal some secrets for us. Anyways, let's get to it. File inclusion vulnerability. Right away, I can notice the page parameter is set to include.php. This might have been more subtle if it just said page equals include or whatever, but seeing that this is a .php script and also that it says page equals, it's really tempting to start tampering with it. It's also the only get parameter we can tamper with in this scenario. So let's see what happens if we try to change it to something that probably do not exist. Alright, blank page, that's fine. What if we set it to, for example, index.php? That would perhaps break the script, but it depends on how it's constructed. But what we see now is that it's hanging pretty much, and it's probably going to time out, and that's pretty interesting. If we take a look in the error log, in the Apache error log, we can see something that might turn into denial of service attack. PHP fatal error, allowed memory size is exhausted. So that could be interesting, but that's not the attack we're demonstrating today. We are going to leverage this file inclusion exploit into a shell. So let's try to make a better understanding of this script. If this script is working as I think it is, I can include any PHP from this system. So let's take the about.php. Let's try to include that. That won't be as simple as just typing page equals index.php. I have to go down one folder, takes me back down here, and I have to go down another one, which should put me in the root of pentest.me, and I'll type in about.php. As I can see, when I mouse over this, I can see it reads pentest.me/about.php. So if I run this script now, it should look just like this. Basically, this increases my understanding of the script and will allow me to further exploit this vulnerability with precision. This should also work. So yeah, this is the front page. Keep in mind, we're still inside the vulnerabilities/file inclusion directory, but we're traversing down the directory structure by using this / syntax. I can further demonstrate the directory traversal, which could be considered a vulnerability in itself, by going back up into the directories, vulnerabilities/v/index.php. This should cause the loop again. I don't want that, the recursive loop, so I'll just do include.php, and absolutely, it looks like we have a good understanding of this script, and that should help us further exploit this. So if .. took me back to the root, I could assume that .. should take me further down a level, .. even further down, and to be honest, I don't care how far down I can go, because I can go all the way back down to slash by just putting in as many .. I want to. And what I'm doing now is I'm traversing into the file system of the operation system, and I want to include files that the script developer did not intend us or wanted us to look at. So let's try to look at a popular file, etc password. This file is included successfully, and we can see the root user up here. We can see other users from the system, and basically this is a nice file to get to verify that you can actually move out of the web directory and include files from the operation system. Now, there's no passwords in this file, despite its name, password. The password actually stored inside the shadow file, but notice that we couldn't get this file. We get a blank page, there's no text on the top, and this is because we do not have read access to this file. So only the root user can actually view the shadow file, and that's a really good thing for Unix or Linux systems for increased protection. Actually, in the old days, there was the password hashes was stored in the password file, and that caused some, well, problems, let's say that. Well, what I want to show you next is for anyone who haven't really exploited file inclusion vulnerabilities before or seen the directory traversal syntax that I'm using. I just want to illustrate what's actually happening in the operation system. If you see the URL up here, I have the data slash and so on. Basically, in the context of the web server and the operation system, it's standing in this directory right here in the /var/www/downloadable web app. This is the working directory for the web server right now, or at least for this host, this web page. So when I'm including data slash, this is what happens. I keep going down. Every data slash keeps going down one directory. So if I do cd data slash, I'm in one directory lower, right? So when I do all the way back, and I can keep going as much as I want to, I have the root directory with all the directories and files in the root. So I did successfully print out the password file. So what's actually happening then is I do like this, and I can double tab, and I can see all the files in the etc folder. Of course, this is cheating because I'm actually in a terminal window on the actual server itself. But here is the password file, and this is the file that I just included. The only thing difference is that in the terminal window it actually properly displays the line feeds, but in my script up here everything is in one line. So basically now we can see that we can include files from the operation system, but what would be some other cool files to include? I mean, the shadow file we couldn't include because we were lacking the privileges, but there might be other files on this system that could be interesting. For example, in my history here I have the message of the day. Well, perhaps it would probably not reveal anything sensitive, but it's interesting to see that we can include it. However, a file that could reveal sensitive information is the MySQL configuration file, and it's interesting to demonstrate how we can pilfer this system for more information right now. In this configuration file, there may be stuff that could reveal weak configurations. It could reveal passwords. It could reveal something more for us to pilfer. For example, we can see the log bin is actually set to this file. It's actually commented out, but even so, we could potentially find more information to pilfer. The same goes with the cron tab. It could reveal sensitive information. It could reveal scripts that would further lead us to exploiting this server successfully. However, I've promised you guys a shell. I haven't promised you to pilfer this machine, so I'll be moving on into how we can leverage this vulnerability into getting a shell on the system. From here on out, I'll be using log files to exploit this system. Log files are great because they are usually a way to reflect some kind of information in them. There is other ways to do file inclusion to shell exploits, or code execution as we like to call it, but I'll be using log files in my example. So log files, every Linux system, even Windows systems, have log files, even though Windows stores them in the event viewer. But in Linux systems, there are a lot of logs in a var log directory, and beneath this directory there is usually a file called messages, and this is kind of a syslog event type of log from the system, and it could reveal sensitive information. It could reveal like when the the server last booted, and so on. But usually it contains stuff like, we see that some programs might be trying to access hardware directly, blah blah blah. Lots of different type of information. Right now I don't see a way how I can somehow inject information into this file. But there are other files. The first one that comes to mind is the Apache 2 error.log, because I could basically produce a 404 with the name that I call it. But in my example right here, I don't have access in reading the error log or the access log, so that won't be working. So what other files could I be reading? Well, there is a good log file called the auth log, and this auth log basically it tells us who has logged into this system before. For example, we can see that root failed logon for root authentication failure on August 16th. And this is something really old. I haven't looked at this log file for quite a while. But if we go all the way to the bottom of it, we should have a more up-to-date entries. On 8, we had the server listening, the SSH daemon listening on port 22. Okay, that's interesting. And there was for cron job, there was a session open for user roots, and so on, and this and that. Well, this is a good place to start testing. What I'm going to show you now is how I'll try to log on with an SSH client into the system and see how the values are reflected back into the log file. So I'll just type it really simple, SSH, it's default port 22, and I'll connect back to my local host. And yes, I want to accept this fingerprint. And it's asking me for password, so I'll type in whatever random I'll just type in some gibberish, and that should prompt an authentication failure. Permission denied, perfect. So I'll Control C, and I'll refresh this log. So let's go all the way to the bottom again. And here we can see failed password for root from 127.0.0.1 on this source port. So that's interesting. Well, I can write root right now. I can make something appear in this log file. So what if I try with a different username, like testing, whatever password, there's probably no such user, and I'll refresh the log file again, and there we have testing. So I have testing up here, invalid user, I have another invalid user, and failed password. So testing is reflected 3 times in this log file, and that's interesting. Well, what else could we put in as our username to properly exploit this system? How about some valid PHP code? Yep, you heard me, valid PHP code as my username. So I'll start off with the PHP tags. I'll keep my PHP code inside these tags, and just for testing purposes I'll do PHP info call. This is a PHP function call which should print out useful information for an attacker. And you have to be really careful. In many cases you only get one try with your PHP code. If you mistype something here, it's going to be included in the log file, and if it's not parsing properly, you're going to have a PHP fatal error and the execution of the script will fail. So this is a one try, one go. If you make it wrong, it's not going to work. So let's hope I didn't make any mistakes in my code. Permission denied, that's fine. And let's see what happens with our inclusion vulnerability. And voila, this is the actual PHP info script being executed. But wait, I've promised you guys a shell, right? That's where we're going from here. We're leveraging this exploit into a shell. So the next example is going to require a bit more advanced PHP code, but not much more. Basically, we'll be using a different username this time. So SSH add localhost 001, and the username I'll be giving it is with the exec function call. The exec function call will take its parameter and try to execute it as a command on the operation system. And I'll be giving it the parameter from the get array, which is a special array populating itself with the get parameters coming in from the URL. So up here. So basically, if I were to access the get array right now, I'll be seeing the page parameter with its value, and I'll be looking for the command parameter. I can call it whatever I want to, but command seems like a fitting word. I'll have to escape the $sign because if not, it's going to turn my bash script. It's going to modify the command a little bit. So I'll escape the $sign, and the rest of the command looks good. So let's try this then. I have the parentheses, I have the brackets, it looks good. So let's try. Alright, bogus password. Control C. And let's see. We shouldn't see any changes in the page right now, but we should see another failed authentication row. So it says failed password for invalid user from this and that. And here is where the username would actually be, but since we are just including just this little PHP script which has no output, there will be no output in the page as well. So let's try something then. Let's try command equals, and keep in mind we have no output. We could have added just like an echo in front of it and we would have had output, but let's try without output. And how can we verify that this command is running? For example, if I give it the command print working directory, we don't have any way of verifying that it's actually working because we don't get any output, right? What can we do instead? Well, we have the ping command, and ping can traverse over networks. So on the other side of the network, we'll just listen for ICMP echo replies, and well, ICMP echoes, and we'll see if this command is running. So I'll be pinging my local host, and before I hit enter, I'll set up TCP dump, and I'll tell it to not resolve DNS. I'll listen on the loopback interface, and actually I'll give it ICMP. I'll only listen for ICMP. So let's see what happens now. And this looks good because it's not reloading quickly. And if we see in the script here, we actually see that it printed out my ICMP echo request and replies. So this is actually working. Basically that verifies that we can actually run commands from the system, and we can connect to, well, we can do pings out on the internet or out wherever we want to. So turning this into a shell shouldn't be too hard, hopefully. Of course it depends on which tools and which that are installed on the server we're exploiting, but netcat is pretty often included. So we'll be using netcat in our example. On my attacker system, I'll be setting up a netcat listener. I'll be listening verbosely, and I'll be listening on destination port 2222. Source port, sorry. So this sets up my attacker machine, and from the compromised server, I'll be doing netcat and to the attacker machine on port 222, and we'll be shoveling a shell. So when this connects to my attacker, it's going to put bin bash into the netcat socket. And here we go. We have a connection coming in from localhost, of course, and if everything is working properly now, we should have bin bash available for us. So let's do ID, and here we see we're running as a www data user, and if we print working directory, we're in the file inclusion directory, which is the directory we're seeing up here. And that's an interesting artifact we're looking at right now. This script is not finished loading until I terminate this netcat session, but that's fine. It's we can see that this connection is still live. So where do we go from here? Well, that's up to you, my friend. This is the end of the presentation, and it's the end of the exploit, and I hope you guys try it. I encourage you to download the downloadable web app and give it a go for yourself. And also keep in mind there's other ways of doing this as well, not only the log files, but that is up for you, perhaps as a challenge to find out what other ways you can leverage file inclusion into a shell. Good luck.